Right. Good morning. So, let's start. Okay. So, unit number 7, separately are taking as a session, where we discuss about the theories with some sort of practicals related to this lesson. Okay. So, especially about the indicators, which usually comes in structured essay questions, MCQs, also. Okay. Fine. It's a very easy chapter coming under chemistry. Okay, very easy. So, initially, we are going to summarize the lesson. We're going to summarize the lesson. Okay. So, summarizing the lesson and then we are going to fill up the two. So, very first, what is the topic? Acids, bases, and salts, right? So, do you have any idea about what these are? What is an acid? What is a base? What is a salt? Salt, you might be right because you are using salt at home. Okay. So, now some sort of theories are there, some sort of misunderstandings are there. Misunderstandings are there. That is, salt in the sense you think always the only salt is what you use at home. No? Lulu? The salt, that is the only salt present you think. Okay. But when you learn this lesson, you will clarify that idea. Okay. Acids and bases also you have used that in your day-to-day routine. Something like, soap water. You used to drink soap water, right? Yes. Okay. Yeah, shaking hands for that also. Right. So this soap water belongs to bases. Vinegar, vinegar, yeah, it is being added to our food, right? So it belongs to acid. So something like this, some sort of examples are there in our day-to-day life. We are using it. We are using them. Okay, fine. So anyhow, what is this acid, base, and salt? It all goes up with the way they act in an acidic in an aqueous medium. Aqueous medium, aqua, it relates to water. Water containing medium. When you take water containing medium in water, how a chemical compound act, how it is behaving. Depending on that, we are dividing them into three. Okay. So when you come for the first one, acids. Acids. So here the acids you take something like this. In a water containing medium, right? It contains water. You're going to apply a component called HA. A component called HA. HA, once you put in water, what happens to this HA is, it is dividing into ions. Basically, it is releasing hydrogen plus ions. What is the ion it is releasing? Hydrogen plus ion. A compound which releases hydrogen plus ions in water medium, in an aqueous medium. Water containing medium, if a compound releases hydrogen plus ion, it is called an acid. It's called an acid. Very simple. What it says? In a water containing medium, if a compound, I'm writing it as AQ. Remember, AQ means aqueous. It contains, it is added to water. So, HA compound you add to water, it releases hydrogen plus ions and the relevant minus ion, both AQ. And both the sides balanced. So, any compound in an aqueous medium, if it releases hydrogen plus ions, it is called an acid. It is called an acid. Anything. And we divide this into two. Some of them will be completely ionizing hydrogen plus. Let's say 100 hydrogen plus ions are there in the compound. All 100 hydrogen plus ions will be released out. Some of them are there partially they release. Out of 100, less than 100 they are releasing. Some they keep it. Some about 70, 80 they are releasing. Or 50, 60 they are releasing. So the remaining is still attached to the chemical compound. You understand? Okay. I got 100 units of hydrogen. So 70 hydrogen plus I'm releasing, 30 I'm keeping with me. So in this way also they can ionize. Ionizing means removing the ion. So one I said completely all 100 released. Released to this medium. So in the water containing medium, all hydrogen plus ions are separated from A minus ions. So this type of acids we term as strong acids. But acids? Strong acids. So acids we are dividing into as strong and weak. So then what is weak acids? Partial ionization. So this is complete ionization of O hydrogen plus. So strong acids belong to who are completely ionizing hydrogen plus ions. Then the weak acids when you're gonna take incomplete or we say fractional or partial. So fractional ionization of whom? Hydrogen plus ions. Hydrogen plus ions. So it is not a neutral atom, okay? It is an ion. Hydrogen plus ion. So completely ionized strong acid, incompletely ionized. What acids? Weak acids. Weak acid. Is that clear what is an acid? So depending on how much hydrogen plus ions it is releasing out, we can divide them as a strong or weak. So then what is a base? Now you know what is an acid, okay? That is the idea of acid. Some examples you have to take, the equations you have to take, and the applications. Bases. Same way, you have a water containing medium again, right? And what do you do? In this water containing medium, you are going to apply another component called BOH. BOH. A hydroxide, we say, like you have heard of these words, like sodium hydroxide, potassium hydroxide, calcium hydroxide. They are very common, right? So such a hydroxide you apply. Now what happens? It's a compound, right? Once put in water, this BOH, AQ, by added to water, aqueous, will be dividing ionizing OH minus. So basic idea is it is releasing OH minus. Earlier it was releasing hydrogen plus. Now this is releasing OH minus. So OH minus gone out means who is the remaining? B, it is plus. So usually we write plus first. So that I wrote the OH minus at the second place. So you see BOH becomes B plus OH minus. So a compound which releases OH minus ions, okay, which ionizes OH minus ions in an aqueous medium, water containing medium, it is written as a base. Base. So this also we divide into two. What are the two? Strong bases and weak bases. Now you know what is strong and weak. How do you say here? This is complete ionization of whom? OH minus ions. And here, fractional ionization of OH minus ions. Fractional ionization of OH minus ions. So, complete ionization, fractional ionization. Complete, partial. So, this is how we divide bases. Right? Is that clear? Right? So, any compound releasing hydrogen plus ion, any compound releasing hydrogen plus ion, it is acid. Any compound releasing OH minus ion is a base. Both happens in water. Not in any other places, only in water. Okay. Then what about the bases and acids added on? It forms our salts. Now what I do? Same like a medium I'm going to take, which contains water. So in a water containing medium only we are adding this, right? Aqueous medium. Because our topic is in an aqueous medium, how it is active, right? So what I do now, I'm going to add HA plus BOH both. Right? I'm going to add both HA and BOH. Both the acid and the base I'm going to add. Right? So what happens here? HA also AQ. BOH also AK. Aqueous medium. Now you know this HA can release H plus ion, right? BOH can release OH minus ion, right? H plus and OH minus combine to form water. And this reaction is called neutralization reaction. What reaction? Neutralization reaction. H plus OH minus, wherever they combine to form a water molecule, H2O molecule, it is called neutralization. It's called neutralization reactions. Okay. And the remaining one would be A minus and B plus. So this A minus B plus, opposite charges, they combine and they form BA. Why I can't write AB? Because A is minus A. B is plus. We give the cation first, right? B plus A minus B8 forms. So BA plus H2O is equal to BaAQ. So can you see now what happened? HA releases H plus, BOH releases OH minus, combining it forms up water, and A minus and B plus forms BA, and this BA is the salt. Okay, sodium chloride is the biggest example for that, but that is not the only salt. There are much more salts. Many more salts are there. You understand that? So accordingly, this is what we are giving as the general form, general equation for salts. So can we divide the salt also strong and weak? We divide them not as strong and weak, but we divide them as acidic and basic. Acidic and basic. So we divide them as acidic, acidic salt, basic salt, and neutral salt we are dividing. Okay. How are we dividing it? Acidic salt. Now you know by the word how it comes. Acidic salt means the salt is slightly showing acidic nature. What is the nature of acid? Which shows that acidic nature. And neutral salt means no acidic, no base. Right? No acidic and no base. And the other one is basic salt. Basic salt. How it happens? Now let's say something like this. Plus 10 minus 6. How much is the answer? Plus 10 minus 6. How much? Plus 4. Minus 10 plus 6. Minus 4. Plus 10 minus 10. 0. That is what happening. Okay. Now, acid plus base is what giving the salt, right? Acid plus base is what giving the salt. If the acid is strong and the base is also strong, strong to strong means plus 2 plus equal. Neutral it is. Plus 10 plus 10 minus 1. Plus 10 minus 10, 0. Salt is neutral. Weak acid to weak base, also neutral. Got it? Strong acid, strong base. Weak acid, weak base, when they added, salt form is neutral. Let's say a strong acid with a weak base. Oh, is strong here. Acid is strong. So the salt form would be acidic salt. Weak acid with a strong base. Oh, is strong. Base is strong. So the salt produced will be a basic salt. You understand? Is that clear? So this is the fundamental part. This is the fundamental part. Okay. So this is the entire fundamental theory about the acids and bases concept. We divide the lesson into two. First about the acids and bases, and then about the indicators. Okay. So that is a practical area. So see, this is the only part. But now we have to write them. We have to write them. We have to learn about the examples. What are the examples coming under strong and weak? How to identify them? How to write their equation? These things are what we have to learn. So did you understand this area? Is it totally clear? Okay, fine. So shall I take a note? Not here. Not here. We have to write on the tube. We have to write a small description about that. So you're gonna take your writing book. Oh, you can use the tube. Just check out the last pages. Check out the last pages. I think maybe 3 blank papers are there, right? Okay. Start from there. In fact, in page number 6 or 7. Page number 9. Page number 9 onwards, you can start. There itself you can start. I want you to write this down first. Take the topic. Acids, bases, and salts. Divide them and mark them. Yeah. But it's A here. A is an anion. A is an anion. Anion is the minus ion in the compound. Okay. And BOH when you are taking B, B is the positive ion in the compound. If you have a question, please ask this. This area should be very clear. You got a question, ask. Someone has a problem. Sorry? Which series? HA is an example that we are taking as a compound. So like X, Y, Z. But if I am taking X here, whom to divide? Only that two arms I can't divide. Got it? So as to show the division of hydrogen plus, because the fundamental part about acids is hydrogen plus should be divided. Sorry, should be ionizing. Hydrogen plus ion should be ionized. So to take out hydrogen plus, I took A. You can take B, C, D, anything. Okay. I just took it as A. So since it is A, here I took this. Okay. So A and B are not real elements. Just a example I took. Okay. So it may be HCl. Now, for an example, HCl, hydrochloric acid, HNO3, nitric acid, H2SO4, sulfuric acid. So likewise it goes on. Okay. So H is present. Removing H means completely or partially it is an acid. That's the idea. Hydroxide. Hydrogen plus ions. OH minus means hydroxide. This is not there again. Yes, there. For OH, we are giving another word also. Hydroxyl ion also is hydroxyl. Hydroxide, hydroxyl, both is. OH minus is a hydrogen. It is a fully element. Okay. If it is inward, so usually it's inward, then it's A2. OH minus A2, like what we have. It is not a solid liquid gas. But because it appears as hydroxide in water in aqueous medium. Yeah. H2O is not aqueous. H2O is water. Water is a liquid. Anything added to water becomes aqueous. Okay. Water we don't say aqueous. But water appears in pure state, right? If it is ice, H2O solid. Liquid water, H2O oil, liquid. Water vapors you take, it is H2O gas. Okay. So physical status, that is what it's important to mention. Okay. So shall I write? Stem. So try to recall within yourself now. Okay. Try to repeat it for yourself. You just read it out in your own words. This is what acid-base gases like. Okay. Sorry, salts. Acids, bases and salts. I'll give you just 2 more minutes. Hurry up. So let's try the acids. So remember those page. Acids. Chemical compounds. Chemical compounds. Take a look at acid. Take a look at first one. Take a look at acids, bases, salts. Okay. And right below acids. Chemical compounds. Chemical compounds which release hydrogen plus ions, H plus ions, which release hydrogen plus ions. Chemical compounds which release hydrogen plus ions, hydrogen plus ions in an aqueous medium. In an aqueous medium. Take the spelling from the part after that. So below the acids, the spellings are there. AQU. EOU is aqueous. Right? In an aqueous medium. So chemical compounds which release hydrogen plus ions in an aqueous medium are called acids. Are called acids. Okay? And only this part you have to write here. Use a different color pen and mark. Only this area. Okay, you have space. Below that description, write this. Okay? Only the box. Only this. Only the box. Right? Only the equation. So make your notes very clear. Okay? You are the one to refer it. So bases we write. Now you know how to define bases. Can you tell me? How do you define bases? Chemical compound which release O, OH minus. Exactly. Chemical compound. Chemical compound which release OH minus ions. OH minus ions in an aqueous medium. OH minus ions in an aqueous medium are called bases. And write the equation there. Bases equation. So salts we write. Chemical compounds formed. Chemical compounds formed by the combination of acids and bases. Chemical compounds formed by the combination of acids and bases. Acids and bases are called salts. Are called salts. Right? Yes. Write the equation there. And these are general equations, okay? According to the examples that we are taking, we have to replace the terms. Right? Okay. Let's move into the next one. The topic acids. Acids. So what does it say? An acid is a compound that releases hydrogen plus ions in an aqueous medium. Correct? So hydrogen plus ion we refer to as a proton. We refer to as a proton. Okay. So now you see, when an acid dissolves in water, so any acids you put in water, what happens is a proton is transferred to a water molecule. A proton is transferred to a water molecule. So that is, what is mean by the word proton? Proton refers to hydrogen plus because usually one proton, if it is present, it should be definitely hydrogen because hydrogen is the first element. And hydrogen has atomic number 1, which refers to only one proton, one electron. So that proton transmitter means what we say it is a hydrogen plus ions form. Okay, hydrogen plus ions will start. So accordingly, what happens actually here is this Ha, when you add in water, okay, Ha, when you add in water, so we write this as Ha ionizes as hydrogen plus and A minus ions, right? This is what the real formula. But in detail, when we are writing, what happens is Ha we put in water. Can you remember the diagram on it? Ha we put in water. Now, this H will be removed, will be ionized. Okay, so this is H plus A minus. So this H plus goes to water and combines with water. Okay. So what happens now is H plus goes to H2O, combines with that. So H2 becomes H3. Oh, it is H2O. Water means H2O, right? H plus is released from HA. So this H plus goes combines with one water molecule, one H2O molecule. So for this H2, when H is added, it becomes H3, right? So it is H3O. And this H comes with a plus ion, right? So this becomes H3O plus. H3O plus. This is what in detail happened. And this is called hydronium ion. Hydronium. So hydrogen plus combining with water, hydronium. Okay. So this comes very rarely. In MCQs this comes. Okay. So this comes in MCQs and such a detailed part under basis we don't learn. Only under SS. Only under SS. So H3O plus A minus. This is what in detail happening. Do you understand what happens here? Something like now this is HA. Okay. And this is water. HA you put in water. Okay. This is the H plus ion. This is the H plus ion. So H plus ion is released from HA. And this H plus ion goes combines with water. Now A minus is there. This is called H2O added with H plus, H3O plus. H3O plus. You understand that? Clear? So this is what in detail happening. Really, this is what happening. Okay, but as a general case, we are writing this part. Okay, that water is related, it is expressed as AQ. Why? AQ means something is added to water, then. So without writing that H2O, we are writing that here. Clear? Without writing this H2O here, straight away H plus A minus, we are writing. That's it. That's only. So why are I giving this part? This may come in MCQs. Okay, it may come in MCQs. So you have to write this just below these two lines. And within the text box, write it with big letters. Use a different color pen to write the equations within these text boxes. 3 equations are there to be written. There you have to write the same color pen there. Okay, right? And acid, bases, salts, such a text box is there for you to write the equations. Use a different color pen. Yeah, right. This also here. This has to be written between this space. After the 2 lines here, correct? You got the point? After the 2 lines here, there's a space, right? Within that space, write this. Within the text box, you have to write this. This is not my so I think it comes out from A. I think of it. And from where it comes. Right? From A, I think some from A. H is the component. Yes. So that B plus and A minus is recovery. That is the H2 is already dense. H2O. If H2O is minus, it cannot be H2O is empty. H2O is what? H2O cannot be minus. So do you understand about this? Okay. So basically you have to remember this. What we learned earlier. Additional this comes in MCQs. In case if they are giving what is the correct equation indicating the acidic reaction, yes, or acid behaving in a water component. So they are giving these parts. Now you are struck right, you don't know what is H3O because you have learned H plus. So that is why I am giving you this area also. This may come in MCQ. Okay, shuffling the terms, they might give you this. So H3O plus A minus, that is how it is. Okay, right. Let's move to the next one. Now I told you the acid we are dividing into 2 based on the strength, strong acids and weak acids. So again, let's say This is totally hydrogen. HA is the compound. This is the HA compound. Total HA compound. This area is hydrogen. So you see, completely hydrogen is released. If hydrogen is completely released, leaving only A minus. And this hydrogen plus ion is added to the medium now. Medium means water containing medium. Okay. Now, this is the component. Hydrogen come to the medium. Hydrogen come to the medium. Within the beaker is present as hydrogen plus and A minus now. This is complete ionization. Complete ionization, if it happens, it is called strong acids. Strong acid. Now let's say after it comes, still some of them are remaining like this. Still, some of them are remaining. Not all hydrogen plus came out. Okay. Part of that came out, part of them are still remaining with A minus. In that case, it is called a weak acid. Weak acid. You understand the point? Okay. So let's move to the next one. Strong acids, weak acids. Examples we are going to take now. Right? What are the examples? It's already highlighted. You can see the terms clearly there. Acids that release hydrogen plus ions by complete ionization. If you have a highlighter, please keep them highlighted. What are the examples? Hydrochloric acid. Now you see, hydrochloric acid, how do we write? HCl. Can you see that? HCl. In HCl, hydrogen plus chlorine minus are there. So can you see completely hydrogen plus comes out and Cl minus is remaining? Correct? Hydrogen plus completely comes out, Cl minus is remaining there. Is there a single hydrogen with Cl? No, right? All hydrogen came out, no? Came out means released, right? It is ionized, right? Then it is a strong acid. Strong acid. But after writing, you have to balance both the cells. Now 1H, 1H, 1Cl, 1Cl. Balance. Sulfuric acid, H2SO4. So when we write sulfuric acid, H2SO4, also A2. Why A2? Added to R. This releases hydrogen plus ions, sulfate SO4 2 minus. So you need to know the polyatomic ions. You have to. That is why I kept on reminding you, learn the polyatomic ions. That is important in chemical formula, chemical equations. Wherever you want to write the equations, you need that. Right? So now sulfate. All hydrogen came released. It is ionized, so it is a strong. But now I have to balance. H2, but only one H. So what I do? I'm writing. And SO4 balanced. Okay? It was H2, right? After ionizing, hydrogen plus comes to hydrogen plus ions, SO4 2 minus. But I have to balance both the sides. Left hand side, right hand side, I have to balance. How do I balance? If it is H2, I can't write 2 here, that's wrong. I have to write the letter, I have the numbers that we are writing to balance should be written in front of the element. So I'm writing 2. Now you may ask me, what about this 2 minus? 2 minus. This is plus, right? 2 into plus, 2 plus. 2 plus 2 minus balanced. 2 plus 2 minus balanced. So both the sides it is balanced now. Okay. So earlier case it was like not like. Not like means because there is no H2, HCl. So it comes as H plus Cl minus. It's already balanced. Plus minus also neutral. Okay. And in this case, HNO. Nitric acid. You have to remember the names. In the questions, they give the names, okay? Nitric acid. What is nitric acid now? It releases hydrogen plus, always the physical states. NO3. You have to correct it. NO3 minus. Correct that 3 minus. It should come down. Minus half. Correct it, please. NO3 minus. Okay. Now check if it is balanced. 1 hydrogen to 1 hydrogen, NO3 to NO3 balance. Plus minus balance. So all the examples show hydrogen is completely ionized. Hydrogen is completely ionized. So hydrogen completely ionized. What acids are they? Strong acids. So just write there here. Hydrogen plus ions are completely ionized. Hydrogen plus ions are completely ionized. Hydrogen plus ions are completely ionized. Okay. Right. Weak acids. Now, what are weak acids? Weak acids, they should be partially removing, right? Removing means, I mean, releasing, right? Partially releasing the ion, not removing, partially releasing the ion or ionizing hydrogen plus. Highlight that. The acids which release hydrogen plus ions in an aqueous medium. The word aqueous medium is a must. Otherwise, we can't just write. It is always happening in a water containing medium. Okay. Incomplete or partial ionization, that is called weak acid. So only a part will be removed, released. What are the examples? Acetic acid. Look at this. CH3 COOH. CH3 COOH. Okay. Now, in this CH3 COOH, H is the ion here to remove. So H plus goes released. It is ionized. So H plus is ionized, leaving the anion. Anion means the minus ion as CH3 COO minus. Now, can you see, is it completely hydrogen ionized? Still some are there. 3 of the hydrogen atoms are there in one anion. What is the name of this? This is called acetate. Acetate. You write them name. Write the names, okay? Acetate. So this is acetic acid. Acetic acid, hydrogen plus ion, then acetate minus ion is released. Now you can see partial ionization. And this acetic acid is what? Present in vinegar, vinagre. It contains 3 to 5% of acetic acid. Okay, it is a weak acid. Weak acid. And that is why vinagre, when you keep it on your tongue, you can feel, you can taste the sour taste. Okay, so that taste is there because of this. Is an acid, right? And carbonic acid. Carbonic acid also we have taste. Where do you taste this carbonic acid? Carbonic acid is what added to fizzy drinks, mega bottles you are taking soft drinks, carbonic acid. Okay, so this carbonic acid is what added on. It is a weak acid. Carbon dioxide contains highly pressurized carbon dioxide dissolved over there, and that is why once you open the bottle, it squeezes out the gas. Okay, but you keep it for some time. All the gas gone out. Now you drink. Will it be giving the same fizzy taste? No, right? The taste is totally gone off, right? It seems to be like water. Just water added with dye. It seems to be. After a while, you keep it opened up. Why? Gas is gone out. What is the gas? Carbon dioxide. Once carbon dioxide leaves out, no more carbonic acid present. Okay. Why? All the carbon dioxide gone out with time. Eventually. That is why no more fizzy taste. Okay. So, anyhow, it is aqueous. You add it to water. H plus comes out, leaving HCO3 minus. HCO3 minus. So, see here, hydrogen is not completely ionized. Some of them are still there. So, it is a weak acid. Weak acid. And phosphoric acid. H3PO4. These are the examples usually come in the waves. Releases hydrogen plus and H2PO4 minus. Here also you can see hydrogen is not completely ionized. Partial ionization, fractional ionization, this is called weak acids. Weak acids. Is that clear? Okay. So mark there. Hydrogen ions are partially ionized. Hydrogen ions are partially ionized. Right. Now you see these acids. Okay, we divide furthermore depending on the concentration. Okay, not only the acid, any solution we can divide like that. We divide them as concentrated and dilute. Concentrated and dilute. Now, concentrated acid means, okay. Now, when you come for a solution, solution contains solute plus solvent. Solute is what you add. Solvent where you add. Mainly we are using water. Okay, mainly we are using water. Right? If water concentration is more than the solute, only a small amount of solute to add in a big amount of water, then this is called diluted. Why diluted? More water present, more solvent present. It's diluted. Right? Now what you do? You are adding some more. You are adding some more. When you want to drink a glass of say juice or something, you are adding the juice powder or the whatever the sort of things that you are going to mix up, you will be adding more. Only you. Because you want to make it delicious, you want to make it very tasty, right? But your friend comes to a company, what do? You have nothing more to be added, but you need 2 glasses. You are sharing and adding more water. Correct? Now what happens? You are sharing into 2 glasses. 1 glass, you are sharing into 2 glasses, and you are adding more water. Okay? Only when you are drinking a cup of tea, nicely you are preparing, when the relatives are coming on, tanni madri, you are adding up. Isn't you are adding more water. You are adding more water, right? Dilute. So concentrated means more solute is added. Diluted means more solvent is added. More water is added. You understand that? So usually in the laboratory experimental setups, we have concentrated bottles. Like the cordial bottles. Concentrated bottles are what you are drinking. You are buying from the market. Straight away you don't drink, right? You have to dilute it with water, isn't it? The cordial bottles that you are taking, you have to dilute it with water. You have to add it with water. You have to mix it according to your requirement. Correct? So concentrated acids bases are what we are having. As per our requirement, what is the level you want to prepare? You have to add water. You have to add water. That preparations and all steps you have learned in unit 3 under mixtures. You have to refer to them. Okay. So anyhow, concentrated acids of higher solute concentration are known as concentrated acids. Higher solute concentration. Acids of low solute concentration. Solute is less, solvent is more, water is more. They are called dilute. Is that clear? Do you understand? So what type of acids usually we have in the bottles? Concentrated. As per our requirement, we have to dilute. We have to dilute it. Most of the acids are concentrated in the laboratories. Dilute acids of required concentration can be prepared by mixing such concentrated acids with water as per the required level. Highlight those two. Right. Now, what are the properties of these acids? What are the properties? Now, when you take an acid, usually in a strong acid, this symbol is there. What it says? It burns your skin. Okay? It burns the skin. It decolonizes or it destroys the materials or furnitures. So you should not pour them into, you should not spill them onto those materials, including your skin. Okay? So it's because of it is corrosive. It is corrosive. It burns out or it makes corrosion over the materials. If it is added to any metals, if it is added with any metals, metals would get corroded. Metals would get corroded. It would be getting, it's reacting with the acid and an acidic layer. Because of the anion it contains, the anion layer combining with the metal will be formed up. Okay. So when acids come into contact with substances like wood, metals, or cloth, they corrode them, and if it's spilled on your skin, they cause harm, severe burns. Figure shows below is a warning symbol. This becomes an MCQ. Warning symbol against, about the corrosive nature of the relevant chemicals seen in the label of the bottles containing concentrated acids. So, first property, acids are corrosive they are corrosive. They do have a corrosive property. Burning. Second one, they have a characteristic sour taste. If you don't have that taste, go home, take some vinagre and put it over. Not to drink. Don't drink that. It becomes a problem. Slightly. Take a bit of a sour taste will be there. Okay. But make sure it is vinagre, not anything else. Okay. And dilute acids react with metals above hydrogen in the reactive series, forming the salt of the metal and hydrogen gas. Third property. Now, any diluted acids added with a metal. Now, reactive series are there. Reactive series, you have to remember now. What is the reactive series? Potassium, sodium, calcium, magnesium, aluminium, zinc, ferrous, tin, lead, hydrogen, copper, mercury, silver, platinum, gold. So above hydrogen, there are elements, right? Above hydrogen, there are elements. In all these elements, dilute acids react. So dilute acid react with metals above hydrogen in the reactive series, forming the salt of the metal. Salt of the metal. That means, for example, magnesium. Can you see? Magnesium is an element. When added with HCl acid, you see what happens? This is plus, this is minus. H plus should go out, right? Why? Because H was medium. H plus should go out. Then magnesium has to combine with Cl because magnesium is 2 plus. Magnesium 2 plus, it is a plus ion, Cl is a minus ion. So plus 2 minus combines. So when it is combining, you must know the chemical formulas. Mg2 plus Cl minus, exchanging 1 and 2, it comes MgCl2. Correct? 2 plus you have to take down, 1 minus you have to take down. So Mg1 Cl2. Cl2, MgCl2. So what is formed here? MgCl2aq. And hydrogen goes out, right? This hydrogen going out will not just move out as hydrogen plus. General idea we learn H plus A minus. But when we are making them into the equations, you have to complete it. Because you can't find hydrogen plus in nature. How it is present, when it goes out as 2 hydrogen connected. 2 hydrogen connected together as H2 gas, it goes no plus. Okay, 2 hydrogen combines and goes out as H2 gas, hydrogen gas. So hydrogen gas will be released. Now I have to balance them. You can see H2Cl2. H2Cl2. But I have only one HCl. So what I do? I'm writing 2. I'm writing 2. Understand how it is balanced? So this is how we are balancing, and you must know the chemical formulas to get the combination 2. So accordingly, you see, a metal react with acid forming the metal salt. MgCl2, metal salt leaving out hydrogen. Let's check with another zinc with HCl. Now tell me how it happens. Zinc is also 2 plus. Then it should be also forming ZnCl2. Zinc chloride. Zinc chloride. Zinc is 2 plus, Cl minus. 2 plus, 1 minus. Same way, zinc Cl2. Okay, it should be formed. Zinc chloride. And what is the gas leaving out? H2. So to balance this H2Cl2, I'm writing 2. 2. Now let's say sodium. Sodium. Okay. And is it always HCl? So it may be some others. I'll take it as HNO3. Nitric acid. Can you remember HCl, H2S servo, HNO3? HNO3 nitric acid. Now it's plus, this is minus. So sodium combines with minus. Okay. Minus means this NO3. Now Na is plus 1. NO3 is minus 1. So plus 2 minus straight away I can write. So how do I write now? It is Na NO3AQ. How do you read this? Sodium nitrate. NO3 means nitrate. Okay. Sodium nitrate plus hydrogen gas goes out H2. Now H2 only one H. H2 only one H. So I'm writing 2. NO3 also become 2 now. 2 N, 2 O3s. But only one N and O3 is there. So I'm writing 2 here. Got it? So H2 I'm writing 2. But since you wrote 2 here, NO3 become twice. So I'm having only one NO3, so I'm writing 2. Now what happened? Sodium became 2. So I'm writing 2 here. So it is balanced. This is how one after the other you have to balance. So it is not always HCl, it may be other acids also. You can see in all these examples, hydrogen gas goes out. Hydrogen gas goes out. This comes in MCQ, structure essay also. Essay type also. Anything it may be. These are possible questions. Okay. You understand that? So any metal above hydrogen in the activity series will be reacting this way, leaving out hydrogen gas. So what is the gas produced? Hydrogen gas. Okay. You understand the point? Can you please write these 2 examples also below there? Write it faster. Mg is already given. The other 2 examples, write that up. Additional examples. What if it is combined with a metal below hydrogen? No reaction. Because when we take the reactivity series, we are dividing that into 3 categories. Okay. Above hydrogen, 2 categories are there: strong reacting, average reacting. Like so, simple words I'm using. Okay. Below hydrogen, no reaction. They won't react because they are physically, they are appearing as native elements mostly. Apart from copper, copper also won't be reacting, but Done? Fine. Look at the next examples now. The other properties. Look at the other properties. What is the next one? Production of carbon dioxide by reacting with carbonates. Now, a carbonate or a bicarbonate you take. A carbonate or a bicarbonate you take. Carbonate, bicarbonate, maybe calcium carbonate, magnesium carbonate, sodium carbonate. So any carbonate or bicarbonate when you are adding with an acid, it forms H2O, carbon dioxide. It forms H2O and carbon dioxide. So remember this, okay? Remember this, right? So carbonates added with an acid forms the metal salt, leaving water and releasing carbon dioxide gas. So earlier you learned the dilute acid with a metal forms a hydrogen gas. Okay, and here a dilute acid with a metal carbonate or bicarbonate forms carbon dioxide gas. Okay, carbonate bicarbonate means CO3, sodium carbonate, magnesium carbonate. Earlier we took directly the acid with the metal, right? So metal added with an acid. Then it forms hydrogen gas, correct? Previously we wrote hydrogen gas. But here it is a metal carbonate or a metal bicarbonate. Maybe sodium carbonate or sodium bicarbonate, calcium bicarbonate. Okay. So like carbonate, bicarbonate when added with an acid, it gives water and releases out carbon dioxide, forming the metal salt. Is that clear? Okay. So this is also an equation. This comes in MCQs too. And the next one, acids. Acids react with bases to form salts and water. Already we learned that, right? Acid plus base gives you water plus salt plus water. Correct? Acid plus base gives you salt plus water. Okay. Acid plus base gives you salt plus water. So accordingly, the salt sodium sulfate. You can see here, it is H2SO4. Tell me, is it an acid or a base? Is it an acid or a base? Acid. H plus is there, right? And sodium hydroxide. Is it an acid or a base? Base. When they are reacting, what happens? H is plus, SO4 is minus. Okay, and in fact it is 2 minus. Sodium is plus, OH is minus. Now they are going to displace, double displace, and exchange is happening. H plus combines with OH minus. Sodium plus combines with SO4 2 minus. Okay. So sodium plus SO4 2 minus. Exchanging is 2 to 1. So it goes Na2SO4. Na2SO4. Right? Na2SO4. And this H plus OH minus combined forms are H2O. H2O. Now we have to balance it. How do you balance? You can see Na2, right? But I have only one Na2. Can you see that? Na2. Na2 came because of this combination. Right? So Na2, but I have given only one Na. It can't be giving one, you can't take two. So I'm writing 2 here. Right? Now what happened? Because of writing 2 here, oxygen became 2. Sulfate to sulfate already balanced. Okay? H2 to H2 also balanced there. But now because of this 2, oxygen and hydrogen becomes 2. Oxygen and hydrogen becomes 2. So 2 into H, 2 hydrogen, and here 2 hydrogen, 4 hydrogen are there. In the input, 2 hydrogen, 2 into H, 2 hydrogen, 4 hydrogen are there. But how many hydrogen I am having here? How many are there? Only 2. So what I do? I am writing 2 to make it 2 into 2, 4. Correct? So 2 hydrogen, 4 hydrogen. I have only 2, so I am writing 2 to make it 4, 2 into 2, 4. Now 2 into 1, how many oxygen? 2 oxygen. 2 into 1, 2 oxygen. And this oxygen 4 balance. Sulfur to sulfur balance. So you see, an acid plus base forms salt plus water. So acid plus base forms salt plus water. Got it? So, what is the salt here? Sodium sulfate. I told you sodium chloride is not the only salt. There are much more salts. Okay, some examples are what you are heading up with. Okay, so can you please write this down below the equation? Equation is already given. Below that, mark this acid plus base. And also, is it always acid plus base? No, base plus acid also give the same. A plus B, B plus A, both give the same thing, right? Okay. Acids turn the color of blue litmus red. This is a simple test used to identify acids. Different tests are there. We term them as indicators. Indicators mean they are the materials which give one color with acids, another color with base. So we can identify if a solution or a liquid is an acid or base because already we know the colors. Already we know what is acidic color and basic color. So you see what happens here. Acids turn the color of blue litmus red. So that means you put blue litmus into an acid, it turns into red color. It turns into red. Turns red. Because the acidic color is red. You put a red litmus into an acid, there is nothing changed. It is remaining red. Remaining red. Because acidic color is red. So you put a red litmus, two litmus colors are there, red litmus and blue litmus. Red litmus you put for acid, remains red. It gives red. It gives red means actually we will do that today inshallah. So when the liquid is rising up, it gives a red color. When you put the blue litmus in acids, it will be turning the red. When the liquid is rising up via the what do you call the blue litmus paper, the blue color change into red color. It turns red. So this is because of acidic color is red. Acidic color is red. This is in litmus papers, okay? Not in all the indicators. Litmus papers, acidic color is red. Okay? Acidic color in litmus, it is red. Can you mark it down, please? Hurry up, hurry up. Okay. All this one we can't eat. That's why total word is on this one, we are adding out. Okay. There are some other salts which we can't use like that. But so that's why I told you salt is not only the sodium chloride part. And always an acid when you add with the base, it will be converting into a salt plus salt. Depending on the strength. Others? Oh. Lime water is not an acid. The lime water is an acid. Alright. So guys, okay. Now, two words always you will confuse. One is lime water, the other one is lime juice. Which one we drink? We drink means we are adding to food or whatever. Is it lime water or lime juice? Lime juice or lime water? Lime juice or lime water? Lime water or lime juice? Lime water. No one? My God. Then is it all adding up with lime juice? Sure? 100% sure. Lime juice is what we are adding. Okay, we are adding lime juice, not lime water. Okay. So this time your percentage is fine. Nah? You said no 100% sure that's true. He doesn't know what he said for you. No? You said for that only, right? So lime juice is what we are adding. Lime juice is acid. Lime water Okay, it is a base. It is used in the construction sites and all. Okay, so lime water. Lime water you don't drink. You don't drink. So lime water is a base. Lime juice is an acid. Is that clear? Lime juice acid. Right. So uses of some acids. What are the uses of acids? Some of the acids are given here. Hydrochloric acid. Just by terms you have to learn. Removal of rust in steel objects. Steel, rusted objects. Again, to remove the rust, they are using HCl. You know, in some countries, they are using as industrial scale, especially the automobile, the what do you call the vehicle bodies when they are getting rusted. The entire vehicle spare part they remove it from the engines and all. They are going to keep it. They are going to immerse it in concentrated acids for long time. So during that time, how all the rusted particles will be removed. Okay, so you can take the body out and you can go for replenish. So those things so far I am not doing it on and off once in a while. Some places they might do, but industrially in some other countries they are doing. Okay, they might start here. Okay, I don't know if already they are doing that, but so far it's not. Okay, so what I mean, these theories when we apply in industries, we can do big changes. Why? The rusted vehicles, we can get a use of them somewhat. Clear? Oh, rusted materials, the iron objects and all, we can get some uses out of them when they are using these stuffs. Anyhow, making gelatin from bony materials in food technology. In food technology, bone materials were, from the bone materials of animals, we extract gelatin. Gelatin, there are two types of gelatin. Plant gelatin, animal gelatin, both of them are there. Okay. Making aqua regia. Aqua regia is a mixture. It is a yellow-green fuming liquid. Green-yellow fumes. Okay, fume would be given. A fuming liquid. And it is a mixture of two acids. What are the two acids? Nitric acid and hydrochloric acid. Concentrated, okay? Concentrated nitric acid and concentrated hydrochloric acid at a ratio of 1 to 3. So the ratio goes concentrated nitric acid, HNO3 to, what is the next one? Hydrochloric acid, HCl. What is the ratio? 1 to 3. 1 to 3 may come in MCs. Okay, so concentrated nitric acid to concentrated hydrochloric acid ratio is 1 to 3. In this way, it is mixed. Where do we use that? We are using to dissolve metal like gold and platinum. Gold, platinum like metals to dissolve. We are using this green yellow fuming liquid aqua regia we say, but regia aqua regia. Okay, this comes in MCQs too. Right? And sulfuric acid. Production of fertilizers such as ammonium sulfate. So we are a sulfate is present. Okay, as a fertilizer. That we are using sulfuric acid. Ammonium sulfate, ammonium triple superphosphate. Okay, and making battery acid. Car batteries using lead acid accumulators also contains foam sulfuric acid. And production of paints, plastics, detergents. There we need sulfuric acid. We don't industrially what is happening, we don't discuss here. Only by as an example. Concentrated sulfuric acid is used as a dehydrating agent. This is important. Dehydrating is to remove water. What is dehydrating? Remove what? Water. Remove water. To remove water as a dehydrating agent, we are using sulfuric acid. Sulfuric acid. So, because of this property, another application is also there. That is, if you want to dry the gases, you take a sample from air. Definitely it contains water molecules. Water vapors are there. So, this air sample, if you want to dry it, how do you dry it? Can you keep it inside the oven and dry it up? Can you put all like the drying clothes under the sunlight? No. Gas. It's a gas. So what you can do, this gas collector, the sample, you can send it via sulfuric acid. Sulfuric acid sample, through the sulfuric acid, you are bubbling the gas. Okay, using some methods. Now, when this gas moves through sulfuric acid, okay, all water molecules, vapors will be absorbed by sulfuric acid. So the gas which comes out in the output is a dry gas. Is a dry gas. So for drying gases also we are using sulfuric acid because sulfuric acid is a dehydrating agent. Do you understand that? So sulfuric acid can absorb water and dehydrate the component. And the next one is acetic acid. In vinegar we are using, okay, and coagulation of rubber latex, rubber glue, rubber Okay, rubber latex to coagulate, to clump it. They are using their production of photographic films. Photographic films to produce, to make. They are also being used for acetic acid, used in paper industries, production of synthetic threads in textile industries. Threads, no synthetic threads to produce also they are using. So accordingly, these are some examples for foam acids and where we use them. Where we use them. So these usages applications we have to just remember. We have to remember this comes in MCQs and is structure is a question. They may ask you to write one or two examples, one or two applications. That's all. Okay. So next we go for bases. You have to learn about what is a base now? A base, it is a chemical compound which releases O, OH minus I. Hydroxide ions, OH minus ions. A base is a chemical compound that increases the hydroxyl concentration. Increasing means it is releasing out hydroxide jet. So hydroxide concentration will be increased. That is the idea. Okay. It is releasing hydroxide. So hydroxide concentration will be increased in the mixture. That is the idea. Okay. So here what happens when a base dissolves in water, proton is transferred from a water molecule to produce a hydroxide ion. Now earlier what we learned, a proton is transferred and combining with H2O. Can you remember? H plus combines with H2O makes H3O plus. Right? So a proton is combining with H2O. Proton is given to H2O in acids. Bases what happen? Opposite. Water gives out a proton. Water gives out a proton. Earlier proton was given to water. Hydrogen plus ion was given to water. Now, from a water molecule, it is giving out a proton. You understand that? Earlier what happened? If acids, for H2O, proton was given in acids. So H3O plus will be formed. In bases what happens? H2O gives out a proton. H2O gives out a proton. You understand that? Earlier in acids, a proton was given to H2O, so it becomes H3O plus. In bases, opposite, H2O gives out a proton. Okay, H2O gives out a proton, so it becomes OH. Proton means hydrogen plus. So from H2O, hydrogen plus, this is hydrogen plus. Proton means hydrogen plus. Hydrogen plus given out means what is remaining? OH minus, correct? So it is a base. And here H2O added with H plus means it is forming H3O plus, that means H plus. So it is an acid. Correct? So this gives H3O plus. H3O plus means H plus acid. This makes OH minus. OH minus means base. So this is what happened. But I told you like this, we don't write a formula here. We don't want that. But ultimately what happens? Let me take BOH in AQ forms B plus and OH minus. OH minus. Write it down. Hurry. Now tell me, what are the two types of bases? What are the two types? Strong bases and weak bases. How do you define strong bases? Complete ionization of O, OH minus, early H plus. Complete ionization of OH minus in which medium? Aqueous medium. Strong base. Incomplete or fractional partial ionization of OH minus in an aqueous medium? Weak base. Okay. So strong bases, weak bases. The bases that completely ionize, highlight. The bases that completely ionize in an aqueous medium are called strong bases. Complete ionizes OH minus ion, okay? Hydroxide ions, strong bases. What are the examples? Sodium hydroxide, NaOH, releases OH minus ions, forming sodium plus. So can you see complete OH minus has come out? Released. No OH added to sodium still, right? All of them have ionized. So both the sides it is balanced. Potassium hydroxide. Sodium hydroxide is what you term as caustic soda. What soda? Caustic soda, right? Some names domestically we are using. In shops and all, you got by sodium hydroxide. Caustic soda is there. They know caustic soda, but they don't know sodium hydroxide. Right? Usual shops, right? But when you go for laboratories and all, you can buy. Even you say sodium hydroxide, you have the bottles, right? So potassium hydroxide, K plus, OH minus. Now K plus OH minus, completely OH minus is ionized. So what type of ionization is? Completely OH minus ions are ionized. So right there, OH minus ions are completely ionized. OH minus ions are completely ionized. OH minus ions are completely ionized. So you can't say that's when the elements or any sort of components are combined chemically and giving a product, in that product you can't find out the initial mass. Got it? Right, weak bases. Look here. What is a weak base? Weak base, incomplete ionization of OH minus ions, right? Can you see for example? Ammonium hydroxide. What is this, boys? Ammonia solution, right there. Ammonium hydroxide. Ammonium hydroxide. Ammonia solution. This is ionizing as NH4 plus OH minus. Can you see OH minus is gone out? But is it completely OH minus gone out? Still some of the hydrogen are there with N. H is a part of OH. H is a part of OH. Is that all H gone out here? All OH? No. Some of the H are still there. Some of the H are still there, means it is a weak. What weak? Weak base. It is a weak base. So right there, OH minus ions are not completely ionized. Are not? OH minus ions are not completely ionized. Are not completely ionized. So what are the properties of bases? Look here. What are the properties? They do have a slimy texture like a soap. Now soap water does have this taste. Now you have used to be with this soap water. You have used up, right? Somewhere it goes to your tongue. Do you drink soap water? No, you don't drink, but it goes to your. Okay. So now flavors may be different. No? What are the flavors? Papaya. Banana. Papaya, right. Okay. So different flavors are there. Okay. Now what is the flavor you using? Velvet Rani? No, they said Rani was they are using. Fine. So different flavors may be there, different terms may be there that we are using, but fundamentally, what is the soap containing a hydroxide? Sodium hydroxide we are using, potassium hydroxide we are using to produce this soap. Okay, we are using it. And this soap, okay, so is a base. So bases, they do have this soap like a slimy texture. Okay, and they can react with acid like the same earlier, acid plus base reacting to form salt plus water, same base plus same equation, A plus B, B plus A, we are writing it. Okay. So base plus acid gives you the salt and water. And litmus papers when you are taking, indicator, litmus papers when you are taking. Acidic color is red, right? Basic color is blue. Basic color is blue. Means, let's say you put a red litmus into a base, right? A red litmus you put in a base, it turns blue. It turns blue. But a blue litmus you put in a base, it remains blue. It remains blue. That means actually when the liquid is rising up, it gives the color blue. So accordingly, what is the basic color? Basic color in litmus is blue. Please write. Acidic color is red, basic color is blue. Acidic color red, basic color blue. Litmus is the name of the material. Litmus is the name of the materials that we are using here. It's an indicator. There are some other papers also that we are using now. Litmus papers, pH papers. Different terms are there. Right? Yeah. Acid and base milk is mixed up. It is a solid. Now, this litmus papers in a solid it is a no color change. Right? Acids and bases combined together form a solvent. So both the acid and base features have been neutralized in a solvent. So in a salt, these litmus papers will not give a color change. Blue litmus or red litmus or equal, no color changes. No color changes. Give. Yes. Why? What am I doing? Acid plus base gives you the salt and water. Okay. For a salt, you add water under condition, then you get somewhat get this acid and base, but under condition. Under condition. Okay. Place on the reverse, you have to properly. Right. Now some examples are there, and also some bases are there readily available. We term them as alkaline solutions. What solutions are they? Alkaline solutions. Listen, everyone. Alkaline solutions. What are they? Sodium hydroxide, potassium hydroxide, ammonia solutions. So these solutions are readily available. These solutions are readily available. Okay, so they are called alkaline solutions. Alkaline solutions. Right? Right. Read the next one. Uses of some bases. Quickly read them. Huh? Alkalize, alkaline. Alkalize, alkali. Right. So uses of some bases. Sodium hydroxide. So sodium hydroxide we are using in laboratory experiments. Okay, laboratory experiments we are using sodium hydroxide. And also to produce soap, paper, artificial silk, paints. In these products also we are using sodium hydroxide and used in laboratory as a strong base. Refining petroleum products. In refining, okay, purifying petroleum products also we are using sodium hydroxide. And then magnesium hydroxide. Magnesium hydroxide suspension. That means magnesium hydroxide added to water, making as a suspension. We are using this. This is called milk of magnesia. We are using this as a relief against gastritis condition. Okay, gastric condition, we say gastritis, acidity in stomach. Okay, so different sort of instant reliefs are taken. The Eno, they are showing up in the advertisements. Right? So this Eno also must contain milk of magnesium. So this is what given. It is a weak base actually. It is a weak base that you are taking. Why usually acidic nature can be neutralized by a base. Basic nature can be neutralized by an acid. So acidity in stomach. In the stomach you are getting an acidity. So what are you supposed to do? You have to intake a base. So you are taking milk of magnesium. So somewhat when you are getting into this acidity, it gives a pain. So you have no milk of magnesium. So what is the base you are having at home? What are the other bases you are having at home? Soap, water, can you think now? Soap is also a base, right? Soap is also a base. Acid neutralizes base. So theory you are going to apply in a wrong practical way now. You are going to drink soap water. What happens? Okay, not because of the acidity you are getting admitted to the hospital, but because of more soap water you drank. Papaya flavor, no? Furthermore, you are drinking. Okay. Right, fine. So, you see properly how to apply. There we are using milk of magnesia. Okay, magnesia suspension we are using. And purification of molasses in sugar industry, sugar canes to purify process. So purification process also we are using more magnesium hydroxide. So it is a weak base. It is a weak base. So is it clear about the acids and bases now? Totally clear about acids and bases? Fine. So sugar canes. Molasses we are obtaining from the sugar canes. From that only we are producing sugar. Okay. So next is about the indicators and then we have to take about the salts. We'll take a short break. Right? Short break. We'll go home. I'll apply powder on your face, okay? Yeah. Fine. We'll have break. 20 minutes. 20 minutes. So now we take the topic salts. Page number 7. Salts. Salt. Take the topic salt. After that will come. Then the salt. And then we'll come. You do the practicals today? Yeah, sure. At the end of? Yes. So, what is this salt? Now you know acid plus base. Acid plus base forms of salt, leaving out water. Right? Acid plus base forms of salt, releasing water. So accordingly, we can write an acid plus a base forms salt plus water. Salt. Both is in the textbook. Yes. Both inside the text. Fine. Now you see, when you take this salt, salts are crystalline, crystal form, and they are solid. Solid crystalline forms, okay, and they can be dissolved in water. Most of the salts are dissolving in water, right? Generally, salts have high melting point and boiling points. Underline. Usually, these salts are having high melting, boiling point. Acid. Listen. Acid react with bases to form salt. Some of the examples are given. Look at this example. Sodium hydroxide. Okay. Plus HCl forms. What is it forming? Look here how it comes. Look how it comes. Sodium plus OH minus. H plus Cl minus. Okay. How they are working up? It is a double exchanging. Okay. Double exchanging. Sodium with chlorine minus. Right. Sodium with chlorine minus. H plus with OH minus. Okay. So, sodium plus chlorine minus forms NaCl. H plus OH minus forms H2O. H2O. Right? So, you see both the sides are balanced. Both the sides are balanced now. So, accordingly, a salt is produced, producing water molecule. Producing a water molecule. Look at this example. What are you doing? Potassium hydroxide. What is this? Potassium hydroxide. Potassium hydroxide plus HCl. Potassium hydroxide plus HCl. How is it forming now? Ka plus OH minus H plus Cl minus. Okay? K plus should be combining with Cl, H plus should be combining with OH. So, potassium chloride is the salt, H plus OH minus water. Both the sides are balanced. Okay. And again, nitric acid upon reacting with magnesium hydroxide. So, magnesium hydroxide is MgOH twice. This is magnesium hydroxide suspension, is it? And HNO3 nitric acid. Magnesium is 2 plus, OH is minus 1. Magnesium 2 plus, OH minus 1. H plus NO3 minus. So 2 plus combines with this NO3 minus. H plus with OH minus. H plus with OH minus. So Mg2 plus with NO3 minus exchange it comes magnesium nitrate. 2 plus 1 minus exchange 1 to 2 it comes. So magnesium nitrate it forms plus H plus OH minus forms H2O liquid. H2O liquid. In all these examples, you can see H2O water is a liquid. Water is a liquid. And now we have to balance it. By balancing NO3 twice, but NO3 only one. So I'm writing 2 here. Now when I write 2 here, hydrogen 2, 4 hydrogen, but I have only 2 hydrogen. So I'm writing 2 here to balance. 2 hydrogen, 2 into 2, 4 hydrogen, 2 oxygen. Okay, 2 oxygen here. NO3 twice, it's balanced. So in all these examples, you can see a salt is produced. Salt is produced. So right here, a salt is produced. A salt is formed. A salt is formed, releasing a water molecule. Releasing a water molecule. A salt is formed, releasing a water molecule. Releasing a water molecule. Right? Now, depending on the strength, we divided them, right? Depending on the strength, we divided them. How did we divide them? How did we divide them? Remember? Acid plus base is that giving you salt plus water, right? Now look here. If it is a strong acid plus strong base, okay, I'm writing right behind, right below that, acid, okay, acid, base, salt, oil. If it is a strong acid, strong base, the salt produced will be neutral. The salt produced will be neutral. If it is a weak acid and a weak base, also gives a neutral salt. Neutral salt. Right? Let's say it is a strong acid and a weak base, then it is acidic salt because acid is strong. And if it is a weak acid and a strong base, it is a basic salt. Basic salt. So this is how salts we are dividing as acidic, basic, and neutral. Acidic, basic, and neutral. So how do you take with the examples? You already know what are the strong acids, what are the strong bases, weak acid, weak bases, examples you. So those examples that they are combining, what is formed will be determined accordingly. For an example, let's say sodium hydroxide is a strong base. HCl is a strong acid. So sodium hydroxide, HCl, when they are combining, sodium chloride form. Sodium chloride will be a neutral one because both the acids and bases are strong. Let's say sodium hydroxide, strong base. Sodium hydroxide, strong base. Okay. Acetic acid, weak acid. Strong base, weak acid. Sodium hydroxide, acetic acid. It forms sodium acetate. So the chloride form, the acetate form here, the salt form here will be a basic salt. Will be a basic salt. Why? Sodium hydroxide is strong basic, acetic acid is weak acidic. So the salt produced will be not neutral, it will be a basic salt. That is how we are determining. Okay. Done with this? Okay. Now what are the examples of these salts? Sodium chloride. As a food preservative we are using. As a food preservative we are using, and also to flavor the food we are using when we are cooking, when we are preparing the meals. To flavor the food also we are using the sodium chloride. Used to produce chemicals such as chlorine, hydrochloric acid, sodium hydroxide, sodium carbonate by solvent process, to glaze earthenware, to make soap, and used in tanning. So several activities are given. In all these things we are using sodium chloride. We are using sodium chloride. So basically in preparing the meals and adding into food as a preservative we are using them. Right? And what is there here? Copper sulfate. Copper sulfate, look here. Used as a fungicide in agriculture. Used as a fungicide in agriculture. Fungicide means against the fungal growth. Against the fungal growth, to destroy them, we are using some stuffs, methods. So using copper sulfate is as a fungicide. Against the fungal growth, we are adding this chemical. Right? And used in making chemical reagents, Benedict solution, Furling solution. Okay, Benedict Furling solution we are using in Benedict test. So monosaccharide, disaccharides to find out, they we use Benedict test. So to produce this Benedict test, we need copper sulfate. Not only that, even in biurate test, biurate reagent, it is a mixture of copper sulfate and hydroxide, sodium hydroxide. Sodium hydroxide, large amount, copper sulfate, sodium hydroxide and copper sulfate. You have to add them in order to test for proteins, biurate test. So they are also unique copper sulfate salt. Used in paint industries. In paint industries we need, and also electroplating as an electrolyte. As an electrolyte to pass the current, we are using copper sulfate because copper sulfate is an ionic compound. Copper sulfate is an ionic compound. Okay, when it is added to water, it can act as an electrolyte. It can conduct electricity. Is that clear? So that is about the salts with examples, right? And neutralization. Solvary process, it is the method of extracting. So some of the methods you'll be learning later under chemistry in grade 11s. In the latter part, in the third term lessons, you'll be learning about them, some of the methods. Okay, right. Now, what is this neutralization? When an acid and a base is combining, okay, when an acid and a base is combining, acid plus base, Now this acid will be releasing hydrogen first, right? Acid means Ha. Let me take Ha first. Ha. And the base is BOH minus. Right? This acid releases H plus. Base releases OH minus. Okay. Acid plus base gives you salt plus water. Right? That means this should be giving you Ba plus H2O. Now, how is this H2O comes? H plus given by acid, OH minus given by base, combines. Combining, this produces H2O. This is how a water molecule is released. This is how a water molecule is released. So, this is the way the water molecule is released. So, this process is called neutralization. So, wherever H plus OH minus combines to form H2O, it is neutralization. It is a neutralization process. So, acid-base reactions are neutralization reactions. And that is why when you have an acidity, applying a base, you can neutralize. When you have a basic nature, applying an acid, you can neutralize. But the thing is, strong to strong, weak to weak, we have to give. Otherwise, you have a weak base, you are adding a strong acid means, then the mixture becomes a basic form. Why? Strong base you add. You have a strong acid. Okay. You have a let's say weak acid. Okay. Weak acid you are adding a strong base. First example. You have a weak acid. You are adding a strong base. So the result becomes basic. Right. Now you have a weak base. You are adding a strong acid. Then the result becomes acidic. Again you have to neutralize it. So weak to weak, strong to strong, you have to apply in order to neutralize. Is that clear? Okay. So slide there. The formation of a water molecule, the formation of water molecule, formation of a water molecule by the combination of hydrogen plus ions, by the combination of hydrogen plus ions released by an acid, and OH minus ions, take out side, OH minus and OH minus ions released by a base. By a base is known as neutralization reaction. Is known as the neutralization reaction. Known as the neutralization reaction. Released by acid, OH minus and released by a base. First we go bottom of this formula. Yeah. Released by a base is known as neutralization reaction. Neutralization reaction. And write it down, please. Done. So accordingly, an acid can be neutralized by a base can be neutralized by an acid. Inam. What's wrong with you? Huh? What's wrong? Why are you all track? You said no track, no? Right? Don't trouble me. Okay? No? Shall I erase? No, I finished writing, right? So accordingly, unlike this, all acid-base reactions are neutralization reactions. So H plus OH minus must be combining to form H2O. Okay. Some other reactions are there, just H2O is formed. So just because of H2O is formed, you can't take it as neutralization. H plus OH minus should be combining in this way. But anyhow, almost this is the way it is happening, right? Because even when the question asks you how a water molecule exists, then you have to write like this. A water molecule exists in this way. H2O exists as, this is not neutralization. This is not neutralization. The question is how a water molecule exists. H2O exists as H plus OH minus. These two should be equal. This is liquid. Okay. So this is if the question asks you how a water molecule exists. Okay. Right. Some examples are there for these applications where we use milk of magnesia and antacid for acidity. Against the acidity in stomach, we are using milk of magnesia. Magnesia suspension we are using. So this magnesia suspension is a weak base. So this weak base when you add, what would happen there? Acidity will be neutralized. Okay, acidity will be neutralized. So you can't take a strong base. Right? Second one, basic substances such as ash and quicklime, calcium oxide. Now, soil acidic, sometimes the soil, because of the addition of the materials, it becomes acidic. The soil acidity you can neutralize when you add a base. What is the base? Quicklime, calcium oxide, or as ashes. When you add there, it will neutralize. The ashes here. Okay? And now the bee sting and the wasp sting. Bee and the wasp, you know, right? Bee, do you know bee? Bees, you know. Bee sting, is it acidic or basic? Acidic. Bee sting is acidic. Okay. Now, bees given, it's harming you with a sting. You get a bee sting. It's acidic. How do you neutralize that? Acidic, you have to apply a base. What is a base you can apply? By applying a weak basic substance such as baking soda. What soda? Baking soda. Sodium bicarbonate. We are using this baking soda in baking. The cakes and all right, for these baking, we are using baking soda. Right? Fine. Calcium carbonate, limestone also we say, on the place of the stain. So we can apply baking soda, calcium carbonate over there. Right? And also, this toothpaste we apply because it is also slightly basic. Okay. So we can apply over there. Soap water also we can apply. Okay, soap water, but the thing is, soap water in a strong way, you have to take it on. Right? Now you are checking for if it is good papaya or honey or will go to, so never mind. It is soap with soap water. Okay. Fine. Now look here. Look here. What is the next one? Last thing. So there's a difference between the bee and the wasp, right? There's a difference. Difference is both seems to be the same, but the position of the yellow color is different. Yellow and black. Almost yellow and black. Okay. So the position of these yellow and black color is a bit different, and the style, the nature of the body is slightly different. And this thing becomes basic. Earlier it was acidic, right? Now it is basic. So for a basic thing, what are you supposed to apply? An acid. Acid means HCl acid you are going to put. Hydrochloric acid, sulfuric acid, nitric acid. Yeah? No, it would be cured. The wound would be cured because there is no more wound at the even the area would be totally burnt up. Okay. If it is an acid. So you have to apply a weak acid. You have to apply a weak acid like vinagre, lime juice. Again, lime juice, not lime water. Lime juice. Lime juice, vinegar. Okay. On the basis of this thing you are going to apply. Right? Yeah. Mother has prepared a lemon juice in the fridge. Now you are going to take the lemon juice here. There will be a different thing at home then. No? That thing is different. Okay. So not lemon juice, it's lime juice. Lime juice. Okay. So accordingly, lemon juice in different stories you can use up, right? So this is lime juice. Lime water we are using as a base. Lime juice is acid, right? So accordingly, acid can neutralize bases, base can neutralize acids. But strong to strong, weak to weak, we have to take. Is it clear? Okay, fine. So now we get back to indicators. So what is this indicators? What is indicators? Indicators means they are the materials which give one color with acids, one color with bases. Or a range of colors with acids, another range of colors, another set of colors with bases. So because of this color ranges given with acids and bases, we can use them to find out if a solution or a liquid is acidic or basic. Why? Already we know the color code. What is the color given? That color related category we have to divide them in. Correct? We have to group them in. Correct? So accordingly, indicators we can use. Some are natural indicators. Naturally, some stuff are there. Some sort of flowers we can use. Okay, some sort of plant materials we can use as natural indicators. Here we are going to use. We are going to speak about artificial man-made indicators. So 5 indicators are there. Okay. So how they are giving the color change, that is what we are going to speak. So let's write there first. The materials. Materials. Yeah, and the indicators correct. Materials. Materials, it doesn't mean always a cloth, okay? The materials which give materials which give different colors with acids and bases. Different colors with acids and bases. Okay. Materials that give different colors with acids and bases. Acids and bases. Okay. Within bracket, one color within that. One color with acids and another color with bases. Maybe one color or set of colors. Okay. One color with acids and another color with bases. Close the bracket. Are called indicators. Are called indicators. Indicators, right? Right. 5 indicators are there. Right there. Litmus papers. Okay. Within bracket, red and blue. Examples you can write down. This space given separately. Litmus, red and blue. Second one, pH papers. When you write pH papers, simple P, capital H. Simple P, capital H. It is a standard way of writing pH. That's because of the theory we don't learn here, but a small idea. Because there's a negative, range we are giving for this pH. According to the negative range only we are giving that. Actually, the negative range of the hydrogen plus concentration. Depending on that only the pH values are given. Okay. So it's a logarithm actually we are giving. So that P is given in simple P. Hydrogen ion is what? Related by H. So H is given capital. So we can't write capital P, capital H. Capital P, simple H. It should be simple P, capital H always. Is that clear? Okay. So always PH should be written as simple P, capital H. Right? So write the second one, PH papers. Third one, what is the word? Read. Phenolphthalein. Phenolphthalein. Okay. Phenolphthalein. L is silent here. Phenolphthalein. Look at the spellings and write properly. You have it on the tube. Phenolphthalein. Phenolphthalein. And the next one, methyl oil or methyl oil. Methyl oil. Magnesium suspension. Magnesium hydroxide, aluminium water is a suspension. So I have okay. Right? Phenolphthalein, methyl orange, and then methyl red. Methyl red. Methyl red. Methyl red. Fifth one, methyl red. Fourth one, you wrote methyl orange, right? Or methyl orange. Methyl red or methyl red. No, it's not there. Additional. You see now? Guys, look at this. Litmus papers when you are taking, it is a kind of, small stripes. Okay, stripes of papers. One is blue color, the other one is red color. Okay, red color. So these litmus papers when you are taking, acidic color is red. That means you put a blue litmus, you immerse a blue litmus in an acid, it turns red. You immerse a red litmus, it gives red. It gives red. In acids. Basic color is blue. Basic color is blue. You apply a blue litmus, it remains the blue. Remains as blue. And it gives the same blue. You apply a red litmus, you immerse a red litmus in a base, it turns blue. Red turns blue. So simply basic color is blue, acidic color is red. Okay. So by origin they are small papers. And then in a neutral salt, when you apply this blue litmus and red litmus, no changes given. No changes given. Is that clear? No changes. pH papers when you are taking, it's a kind of yellow color papers. Yellow color papers. And these papers, they do have a range actually. 0 to 14 range is there. We take it as the pH scale. Right? So simply when you are taking the papers, within the papers, there will be colors given. A range of colors. I told you maybe one color or a range of color. What is the range of color? If it turns, once you immerse these pH papers, yellow color papers into a liquid or a solution, if it turns red, orange, yellow, any of these colors, it should be an acid. It should be an acid. If it turns dark green, blue, violet, any of these colors, then the substrate should be a base. Substrate should be a base. So acidic colors, red, orange, yellow, basic colors, dark green, blue, violet. Okay. Phenolphthalein you take. It's a powder, right? So it's a white color powder. It is dissolved in ethanol or surgical spirit. Ethanol means ethyl alcohol or surgical spirit. We dissolve and we prepare this phenolphthalein. Now this is phenolphthalein spirit. Okay. So this phenolphthalein is colorless. It is colorless. When you add this phenolphthalein into acid, it is colorless. No color change. It remains, it gives the same colorless stuff. But if you add this into a base, it turns pink. It turns pink. It seems to be like magic, right? These are what they are using in magic. I told you in magic, it's totally physics. The magical stuff they are doing using science, using physics. Okay, using chemistry. Some other. Okay, so using physics. This is a chemistry lesson. Okay, physics and chemistry is what they are basically using in the magic shows. Okay, so the color changes, combined color changes. All these are given black. And you see, phenolphthalein, colorless in acids, bases it is pink. And methyl orange, methyl red. Methyl orange when you are taking, it is a yellow color powder. Mixed up with water. So it gives yellow color solution. Okay. Methyl red, methyl orange, both. Okay, both. Structure they are different, but both of them in acids they give red color, bases they give yellow color. Acids they turn red, bases they turn yellow. Okay, so accordingly, these are the 5 indicators that we are supposed to learn. Okay, and furthermore, when we take these indicators, we are using to identify if a liquid or a solution or a component is acidic or basic. When you come for litmus papers, we got 2 litmus papers, right? Blue litmus and red litmus. Blue litmus, red litmus. So, when you take the red litmus, okay, red litmus, we apply red in acids, it remains red. It remains red. Okay. Red litmus you apply in a base, what happens? It turns blue. So, red you apply in an acid, what happens? Remains red. Okay. Red you apply in a base, what happens? Blue. It turns blue. Right? RAR, RBB. Okay. This is going off with red litmus. Red litmus. And the blue litmus when you come, blue litmus, you apply the blue litmus in an acid. You apply a blue litmus in an acid, what happens? The blue litmus turns red. Turns red. You apply a blue litmus in a base, it remains blue. It remains blue. It gives blue. So these are the color changes. These are the color changes. So now, what about a strong acid, weak acid? Strong or weak? Okay. Acidic color is red. Strong or weak, acidic color is red. And strong or weak, basic color is blue. So you see, use what I doing? Huh? When we are using these litmus papers, we can find out if a solution is acid or base only. How much acidic, how much basic, we can't figure out. How much is the strength of acids and bases, we can't figure it out. Using pH papers also the same. When we are using the pH papers, the yellow color papers, okay, we can find out if a solution is acidic or basic only. How strong they are, how weak they are, we can't give a number. So we are heading up with pH scale. pH scale when we come 0 to 14 numbers are there. For all those numbers from 0 to 14, there are relevant colors. And if that relevant color is given, we find out how much stronger or weaker acids and bases the components are. Okay, so that is the pH scale. So before we go for that, will you please mark this down? Yes. Are you done? Okay. Next part. Done? Can I please? No, no, only this. That's enough. They have given more space there. You're supposed to do something, but no need. That's right. Fine. So the next one goes up with the pH papers. Okay, pH papers. So the pH scale actually. pH scale when you come, I told you, not only if it is acid or base we can find, but how much stronger they are also we can, find out. So that is because of this pH scale when you take, it does have some color in it. Look at this. What is the color? 0 to 40 numbers are there, starting from 1 here. Fine. Now, like this. 7 is neutral. Can you see? pH 7 is neutral. 0 to 6 or 1 to 6 when you are taking, it is acidic. It is acidic. Okay. So when you take from this level, it is acidic. 8 to 14 you take basic. Basic. 7 is neutral. Neutral. Okay. When the color, we see red color, pink color, like if a color is given, it is a strong acid, very acid, strong acid. A number close to the neutral value, somewhere like 5, 6, this lime green, yellow, green, those colors are given, then it should be a weak acid, slightly acidic. Now with a component, if this color change is given when you apply pH papers, it is slightly acidic. And then it becomes neutral. Neutral means green color. Okay. And then it becomes very dark green or else turquoise. Now the green blue mixed color is there. Such a color is given means it should be a slightly alkaline. Slightly alkaline means slightly basic. Alkaline refers to basic. Basic. A weak base. A weak base. If it gives a number closer to 12, 13, 14, dark purple, violet, those colors given means it should be a very strong basic. Very alkaline. Very alkaline. So accordingly you see 0 to 14 when you are moving on. 0 to 14 when you are moving on. Acidic nature. So acidicity is increasing or decreasing? Decreasing, right? Why? Very strong, weak. Acidic nature is decreasing from 0 to 6. And then basic nature is again increasing from 8 to 40. 8 to 40. So this is how you find out if the component is strong or weak, acidic, basic. You understand? So the color changes are given over there. Here you can see the colors: red, pink, orange, beige, yellow, lime green. Acidic. Okay, acidic. And green also. Green, it is neutral. Dark green, turquoise, and pale blue, blue, dark blue, violet, purple. These colors are basic. And some of those colors are what under pH papers you took. Okay, what are the colors? Red, orange, yellow. And here, green, dark, blue, violet. Those colors we took under basis. So can you please mark them? Right, I done? Finished. So that's all about the theories. Okay. Any questions out of them? Any questions? Right. Okay. So we have to head up with some practicals related to these indicators. Okay. First, I will show you how it works. Okay. And then I will just pass both the sides where you have to do in your own as a group. Okay. You have to practically do that. Is that clear? I'll pass the materials to you all. Okay. So separately, you have to do it. You have to practically check it out how it works and you have to list it. You have one page remaining like this on your view. Okay. So you can utilize those pages in order to list them out. Some of the materials with the name, what is the color change is one, with whom the color change is one, you have to work out. Fine. Have a look. Could you move there? Yeah. So I told you guys come closer. Then it will be easy, right? Can you see the board? See the board? Fine. So anyhow, you see here, it's really It's salt here. Sodium chloride added with water. Salt solution. Okay. It's totally salt solution. Now to the salt solution. It's mixed up. The samples I'm taking here. Salt solution, is it acid base or salt? What is it? It is a salt, right? Salt means, let me add phenolphthalein. Will it be giving any color changes? No color change. No color change. Phenolphthalein, no color change. pH paper. Can you see the same thing? No color change. Brown color? No, you have to look for the lower part. Okay. No color change, right? Okay. pH papers, no color change. No color change. And litmus papers also you put, no color changes. Both no color change since it is. So no color changes. Okay. No color changes. Red, blue litmus. And then again, red litmus you apply. Also has no color changes. No color changes. Okay. Can see no color changes. Yes, right. So accordingly, this is how one by one we have to check in this way. Okay. And one more thing we take. What about the soap? What about soap? So I'll take a soap sample, right? And you have to mix it with water because you have to make soap water. Hmm? Yes. So it's totally soap water here. So actually, you have to grind it well, but even if it is having particles, fine. It won't be an issue. Yes, but before that, I'm going to take the papers. Okay. Now, look at this. You can see over there, right? I'm going to take a red litmus paper. Okay. Look what happens. Yes, it is soap water. Can you see red litmus turns blue? Red litmus turns blue. Red litmus is turning blue. Okay, it is red, but it is turning into blue. Okay. And a blue litmus paper, when I add, what happens? Is it giving a change? No change. No change. It remains blue. It remains blue. What if it is a pH paper? If it is a pH paper, what is the color it should be giving if it is a base? Can you see? Green color. Dark green like. Okay. Like normal green, neutral. Dark green. Okay, it is dark green. Okay. Dark green. Dark green. Okay. No, it's because of what added. If it is diluted, it happens. Okay. And then look at this. Now it is phenolphthalein. What is the color change you should be giving? Can you see it's turning into pink? Turning pink. You can't see. It's turning pink. Right? You will do, no worries. I'll pass you to do it. Is that clear? It turns pink with a base. It turns pink with a base. Okay. But sodium carbonate, when you are testing again, you have to check it out if the same color change given, if it is totally changed. Because any other mixtures, what do you call it? Totally mixed up, let's say, messed up, let's say, then the result would be also negative. Results will be also negative, it will be giving you. And one more thing I'm going to do now, that is a small cotton I have. Okay. And this cotton, I'm going to take it with soap water, actually. So let me take soap water. Now, what is the color of the cotton? What is the color of the cotton? Cotton is white color. Okay. You know that drill, no? Yes. The cotton that we are using. No, it's totally cotton, right? It's cotton. Okay. What I do for this cotton, I'm going to add some phenolphthalein. What is it changing into? Can you see it's changing into pink color? Correct? It's changing into pink color. Why? Cotton I have dipped with soap water. Soap water is base. Phenolphthalein, when you add, it turns pink. It turns pink. So we are doing it in experimental level. This is taken in, behind the scene, like they make this as a magic. Color changes. Okay, is it clear? So these are fundamental stuffs. These are the fundamental stuffs, right? And fine. Now, sometimes you might have seen some sort of things like this. That is, some letters they are writing on the board. Okay, some letters they are writing.